Finance Core, Topic 3, Discounted Cash Flows, Debt, and VBA. References include Chapter 4, Discounted Cash Flow, and Chapter 5, Interest Rates and Bond Valuation. Learning objective number 1, we're going to compute the present value and future value of lump sum payments. Lump sum payments mean single payments in the future. So let's talk about some valuation principles. Number 1 is an important term called time value of money. What this means is $1 today is worth more than $1 tomorrow because you can invest today and earn interest. So for a simple fact, I'd rather have $100 today than $100 a year from now, because I had $100 today, I could invest it and have more than $100 a year from now. Now the term present value refers to the value today of a future cash flow. So how much I would pay today for, say, a amount of money next year. And the term future value refers to a future value at a certain date of a cash flow. For example, if I invest $100 in a savings account at 2% interest, I'd have $102,000 next year. So my present value is $100,000. My future value of that $100,000 is $102,000. Conversely, you can say that the future value of $102,000 has a present value of $100,000 at an interest rate of 2%. Now, cash flow and value additivity. We talk about valuation. We're going to be taking the present value of all expected cash flows, and you can only sum up cash flows of the same period. And what we're going to generally do is compute all future cash flows back to the present and add up all the present values. And the interest rate which you use to convert cash flows from the present to the future, that interest rate should reflect the risk of the project, and is often the cost of capital or financing rate, but that's a later topic. So let's start off with a real estate example. A real estate company can sell a property for $1 million today with certainty, or they could wait and sell it for $1.05 million with certainty 1 year from today. Now, which should they choose if they can invest risk-free at 4% per year? Well, I can calculate the future value of both alternatives, $1 million today or $1.05 million next year, and later I'll calculate the present value of both alternatives, and that's how we compare which one we should do. So the first formula we're going to talk about is the future value of a single lump sum or a single payment today. Is we say the future value at year t or time period t is equal to the present value times 1 plus r to the t, where PV is the amount invested today or received today, and r is the interest rate earned over that period of time, and t is the number of periods. So if I want to compare whether I want to receive $1 million today or $1.05 million next year, one way to do it is I can compare this $1.05 million to the future value of this present value. So this is already a future value. So I want to convert this one to a future value. So if I were to receive $1 million for that property today and invest it in the bank, or say this risk-free interest rate at 4%, I can plug in my formula and I'd have $1.04 million 1 year from now. So now I can compare that selling it for $1 million today has a future value 1 year from now of $1.04 million, but waiting a year I can get $1.05 million. So obviously I want to wait a year and get $1.05 million because the future value of is greater. But you can do it the other way. This is actually the more common way to do it. Convert them both to present values. So if I can get $1.05 million next year, how do I talk about that compared to $1 million received today on the first offer? Well, I'll rearrange the formula from the last slide and say the present value of a payment is equal to the future value of the payment, so that's the $1.05 million received next year, divided by 1 plus r to the t power. So I'll take my $1.05 million, divide by 1.04 to the first power. So that $1.05 million has a present value of $1,009,615. So the present value of $1.05 million received next year is $1,009,615. Now it's another way to see quite clearly that I should wait. The present value of the $1.05 million exceeds the present value of receiving $1 million today. So it's just another way of doing the analysis. But it's important to notice that you need to convert them both to future values or both the present values. Now, what about if there's some risk? So what if I have an offer for $1 million today? However, what if there's some risk on that, say, future payment? So let's talk about a third option. What about waiting 2 years for a 25% chance of getting 1.2 million or a 75% chance of getting $1 million 2 years from now? How would that compare to selling it for $1 million with certainty today? So what we do is we're going to calculate the expected present value, the expected cash flows, and take the present value of the expected cash flows. So I'm going to have a 25% chance of getting 1.2 million and a 75% chance of getting 1 million. So let's get the expected cash flow. So I'll go to the spreadsheet. I'm going to take my 1,000,002 times 25% plus 1 million times 75%. So the expected cash flow is actually probably, the risk-adjusted expected cash flow, adjusting for the probabilities. It actually has an expected value of 1,050,000 2 years from now. If I take the present value of 1,050,000 2 years from now, take that future value over 1 plus the interest rate raised to the 2 power, that's 970, 784. So what you see is the expected value of waiting 2 years in present value terms is 970. So you know what? I'm just going to sell it today for $1 million, or I'll sell it, say, next year and have the present value we already calculated here of 1,000,009. Now you can do some what if analysis in this case. What is the probability of getting 1,000,002, or what probability of getting 1,000,002 2 years from now would make this the best option? So we already said that the best option right now has a present value of 1,009,615. So if I go to my spreadsheet and I have this probability of 25%, I could do a data, what if, goal seek. I want to set the present value to 1,009,615 by changing that probability. So again, I'm going to set the present value to 1,009,009, which is the best alternative, by changing the probability. That probability is 46%. So what I could say is, if I think if there's more than a 46% chance of getting 1,000,002, I would wait. If there's less than a 46% chance, I would sell it 1 year from now and get that present value of 1,009,009. All right, let's take a look at Excel's PV and FV functions. So instead of doing my formula, I've used that present value is equal to future value divided by 1 plus R to the T, and rearranging that. I just want to show you here that here's the formulas we calculated in the first couple slides. That is my present value times 1 plus R to the T power. I can also use the FV function. FV function, here are the parameters. It is the rate, that's the 4%. The number of periods, 1. The payment, that's going to be 0. So payment, it's a little confusing here. Payment is a number of, or is multiple payments. We'll talk about those in the next section. However, in this example, there's a present value of $1 million, and we're just trying to calculate the future value, and the result is 1,040,000. Okay. Now notice if I don't put a negative sign in front of this million, the answer turns out to be negative. So I like to show numbers as positive. So what I'm going to do there is I'm just going to either change the sign in front of the equation, or just change that present value. Whoops, let me come back over here. I could just change the sign here, or I could just change the sign of the present value. And then here's the example of the PV function. What is the present value of a future value of 1,050,000? Again, I put a negative 1,050,000 in there. 0 payments, 1 period, 4% rate of interest, and I get 1,009,009. And then I do it again here. Here's another present value. The present value at 4% 2 years from now of a future value of 1,050,000 is 970. So there's the PV function. To access these functions, or to use these functions from scratch, all you need to do is click on this little f of x. You could look for your function like PV find your function, hit OK, and then you can put in your parameters here. Say 4%, 2 periods, no payments, but a future value of $1,050,000, and that's how you input that function right there. Notice it's a negative number, so I can either change that to a negative, switch that to a positive, or change this to a negative and just switch it to a positive just for presentation purposes. Okay, so let's go back to our real estate example. Suppose a fourth real estate offer comes from an investor that would like to purchase today with an installment plan to pay $500,000 today and then $250,000 a year for the next 3 years. So what is better, taking this installment plan or getting the the 1 year payment has a present value of $1.9 million? Well, the only way to compare these is to do present values, because if I just add up the cash flows, right, these cash flows add up to $1.25 million. That looks like the best. But again, you can borrow and invest at 4%. So, or invest at 4%. So it's not clear whether this is better than a present value of $1.9 million. So how we're going to do that is we'll just take the present value of every cash flow and add it together. So I'll do a little trick here. I'll start with the last cash flow. I'll take $250, divide it by 1 plus the interest rate. I'm going to hit F4 to anchor that, or put $ signs in front of C and 1, and raise that to the 3 power. So the present value of $250 received 3 years from now is $222. I'll copy those formulas up. Notice this last formula is 500,000 over 1 plus r to the 0 power. Anything to the 0 power is 1, so it's effectively just dividing $500,000 by 1. I'll then sum all these up and see the present value of this installment plan is $1.193 million. Actually, it is clearly the best answer, or the best offer I have. So I would choose this as long as it's certain I'm going to receive these cash flows. The answer would change if there's some chance they never pay me. So in this topic, we computed the present value and future value of single lump sum payments.